In 1987, two very tall German engineers walked into a room, sat down in a mock-up of a car that had been in development for 6 years, and banged their heads on the roof. What happened next cost Mercedes-Benz over $1 billion, delayed the car by 18 months, and produced a machine so comprehensively over-engineered that the company spent the next decade recovering from the financial consequences of building it. It also produced what many engineers, historians, and automotive journalists still consider the greatest luxury car ever made. The car was the Mercedes-Benz W140 S-Class. And this is the story of how two men hitting their heads on a prototype ceiling changed the entire automotive industry. The mandate. Development of the W140 began in 1981 at a time when Mercedes-Benz occupied a position of almost unchallengeable dominance in the global luxury car market. BMW was growing but not yet threatening. Jaguar was faltering. No Japanese manufacturer had yet made a serious attempt at the segment. Mercedes stood largely alone at the top of automotive engineering and had done so for decades. That comfort could have produced complacency. Instead, it produced ambition. The engineers assigned to develop the W140, the replacement for the highly regarded W126 S-Class, were given a mandate that had never before been attached to a production car program in quite this way. No compromise, no budget ceiling. Build the best car in the world, whatever it costs, and do not come back until you have done it. The program was nicknamed the Cathedral, not because of any religious significance, but because of the scale and complexity of what was being constructed inside it. Like a medieval cathedral, it was extraordinarily expensive, took far longer than anyone had planned, and was being built with a level of craftsmanship that the people funding it sometimes questioned the sanity of. Unlike a medieval cathedral, it had a deadline. It missed it by 18 months. The head incident. In 1987, the W140 program had been running for 6 years. A definitive exterior design by French designer Olivier Boulet had been approved in December 1986. Production was on track for a launch at the Frankfurt Motor Show in September 1989. The engineering team was finalizing details. Things were, by the standards of what was coming, going relatively smoothly. Then Wolfgang Peter, the chief engineer of Mercedes-Benz, and Rudolf Hornig, the car line manager, visited the styling laboratory to evaluate the ergonomics of the cabin mock-up. Both men were at least 6 feet 3 inches tall. Both men sat down in the mock-up. Both men banged their heads on the roofline. In unison, they said the same thing: "That's great now," as the roof was lifted off to give them headroom. The decision made in that moment was not complicated. The car needed to be taller. That decision required redesigning the body. The body redesign required re-engineering the suspension geometry. The suspension changes affected the chassis dimensions. The chassis changes required revisiting the aerodynamics. And on through every system in the car, because in a vehicle designed to this level of integration, changing one thing means changing everything connected to it. The car grew. Width increased by 3 inches over its predecessor. Height by 2 inches. Weight, depending on variant, by 700 to 800 pounds. The launch date of September 1989 was no longer achievable. The program would not be ready until March 1991, 18 months later. Wolfgang Peter, the chief engineer who had been responsible for the program's development, did not stay to see the launch. The cost overruns and the delay cost him his position. He left Mercedes-Benz before the car he had led the development of was ever shown to the public. The V12 problem. The roof incident was not the only thing that extended the W140's development timeline. In 1986, while the Mercedes engineers were working on their new S-Class, BMW announced something that landed at Stuttgart headquarters like a thunderclap. The new BMW 7 Series, the E32, would be available with a V12 engine, the first V12 in a German production car since the Second World War. BMW had kept the development entirely secret. Mercedes had no idea it was coming, and when the announcement arrived, the reaction from the Mercedes-Benz board was immediate and unambiguous. They could not launch the most expensive and most ambitious S-Class in the company's history without a V12 engine of their own. The engineering team was given 18 months to design, develop, and validate an entirely new V12 engine. 18 months. For an engine that would normally require 4 to 5 years of development, they did it. The M120, a 6.0-liter naturally aspirated V12 producing 402 horsepower, was ready for the W140's launch and was not only more powerful than BMW's competing unit, but became the lightest V12 engine in the world for most of the 1990s. Versions of that engine would go on to power Pagani supercars and various Mercedes performance vehicles for years afterward. But developing the V12 in 18 months while simultaneously redesigning the body, chassis, and suspension meant that the engineering team was now running multiple parallel programs of extraordinary complexity simultaneously. The cost was escalating, the timeline was extending, and the engineers, given their no-compromise mandate, were not stopping. What they actually built. The W140 that finally arrived at the Geneva Motor Show in March 1991 contained a list of engineering innovations that the automotive industry has spent 3 decades absorbing and standardizing. The windows on the W140 were double-paned, not because anyone had requested soundproofed glass in a passenger car before, but because the engineers analyzed the sources of cabin noise and identified the windows as one of them. They fixed it. The doors were lined with acoustic insulation so thorough that closing one produced a sound that automotive journalists consistently described as vault-like. A mechanical thunk of such solidity that it communicated structural integrity before you had even sat down. The doors also featured a self-closing mechanism. Close a W140 door most of the way and it pulled itself shut for the final few millimeters, ensuring a perfect seal every time without requiring the occupant to slam. The boot lid operated the same way. The windows lowered automatically when the door was opened to clear the frameless glass from the seal, then rose to close perfectly when the door was shut. Every contact point in the car was engineered to operate with the precision of a Swiss movement. The parking situation was addressed with guide rods that extended from the rear corners of the boot lid when reversing, giving the driver a visual reference for the car's corners in an era before parking sensors existed as a commercial product. Mercedes was solving problems that most manufacturers had not yet identified as problems. The heating system could be programmed to continue emitting warm air for a period after the engine was switched off. In winter, in a cold climate, you could leave the car, return 10 minutes later, and find the interior still warm. This was not a feature that any customer had asked for. It was a feature that Mercedes engineers thought the car should have. Speed-sensitive steering, which the company called parameter steering, adjusted the steering weight based on vehicle speed, light and maneuverable at low speeds, weighted and stable at motorway speeds. Electronic stability control arrived as an optional feature in 1994 on the facelifted model, the first time this technology was made available on a production car. The system used computers and sensors to prevent the vehicle from losing control during cornering, braking, and evasive maneuvers. Every car with electronic stability control built since that moment owes a debt to the engineering program that put it on the W140. The environmental thinking was equally advanced for its time. The air conditioning refrigerant was CFC-free R134A rather than the ozone-depleting R12, used by virtually every other manufacturer. Plastic components were clearly marked for recycling purposes and manufactured with a significant proportion of regranulated plastic. In 1991, this was not a regulatory requirement. It was an engineering decision made because the team thought it was the right thing to do. The W140 cost Mercedes-Benz over $1 billion to develop. When it launched, its price was 25% higher than its predecessor, the W126, which had itself been considered expensive at launch. The starting price for a 6-cylinder W140 in the United States in 1992 was $71,500. The Lexus LS 400, which had launched 3 years earlier, offering comparable refinement and reliability at significantly lower development cost, started at $44,300. The Japanese had arrived. Sales of the W140 were lower than Mercedes had projected throughout its production run. The recession of the early 1990s, the price premium over competitors, and growing awareness of the Lexus alternative all reduced demand. Total production reached 432,732 units across 8 years of production, which by any normal measure is a successful run but fell short of the volume the company had needed to recoup the development investment. The overruns and the commercial shortfall forced Mercedes-Benz into a decision that many enthusiasts consider the most consequential in the company's modern history. After the W140, the accountants were given a seat at the table that the engineers had previously occupied alone. The next S-Class, the W220, launched in 1998 with dramatically reduced development costs, a lighter build approach, and a much more market-driven specification process. It was also, by broad consensus, not nearly as good. Early W220s suffered from rust, electrical problems, and reliability issues that would have been unthinkable in a W140. A class action lawsuit was filed in the United States over ventilation drain leaks. Nearly all Chinese market W220As required recall. The W140 was the last Mercedes built on the principle that the engineering came first and the budget came second. Every Mercedes since has been built the other way around. Many enthusiasts argue that this makes it not just the most over-engineered Mercedes ever built, but the last real one. Why it matters. The W140 introduced electronic stability control to production cars. It introduced double-pane acoustic glazing to the segment. It introduced self-closing doors and boots. It pioneered the use of CFC-free refrigerant in automotive air conditioning. It produced a V12 engine in 18 months that went on to power some of the most celebrated performance vehicles of the following decade. The car cost so much more than its competitors that it lost market share to the very Lexus that its existence had been designed to outclass. That is the story of the over-engineered car built to change the world. It changed the world. It just could not survive the consequences of doing so. The company that built it decided it could never afford to do it again. Both of those things are true simultaneously. That is what over-engineered actually means when it is done completely right. Subscribe and hit the notification bell so you never miss a story like this one.